So the first thing I want to show you is this right here. This guy named Kenneth Field. He is a cartographer. This guy has been sort of an inspiration to me when I've been getting into GIS and mapping. Maps are a device for storytelling, and that's one thing that we're going to try to emphasize in our class as well. It's not just representing data. It's very much a subjective perspective on what you want the data to say to the audience that you are presenting the data to. He basically based this entire book on the whole idea of election maps. I encourage you guys, if you are getting into maps, it's worth taking a look at this book. You can get it on Kindle. I got it on Kindle, so you can just instantly buy it. He provides this link here where basically he uploads several versions of the election maps, visualize and see high-res versions of all the ones that he talks about. So what I've done already is I've given you 2020 Pres election data by county. These two CSV files I downloaded from this data set, or this website right here, this election mit.edu data website here. And I basically took those spreadsheets and I cleaned them up and then joined them into county data set. And so if you unzip that file and bring it in, you will see something that looks like this. Before we go further, whenever you create maps in GIS, it's always good to just make sure you're using a good coordinate system for whatever you're doing. So this is obviously a sorted map of the United States. So what we're going to do is we're going to use a coordinate system called contiguous USA Albers. And now you can reproject this. So now this is a more accurate representation of the scale of United States. If you go into the attribute table of this data set, so I right click on the data, go to attribute table, you'll see that in here, you will have the county information right here. Right here, there is a Republican and Democrat and total. Also did a margin of victory. So basically I took the Democrat count and subtracted it from the Republican count to get a margin of victory. You can go into the Symbology tab. So click on Symbology, go to the graduated colors option in the Symbology button there. And this allows you to visualize something by any numerical quantity. In this case, let's just go with the Republican option there. And you can see that basically highlights and colors the cells by the number of votes and gives a gradient to that. Typically, whenever we see these election maps, you would expect that Republican, the color fill is something like a red color, and then Democrat is something like a blue color. And what you really need to understand is not necessarily the total number of votes as it relates to the other number of votes, but rather the proportion of the Republican votes to the total amount of votes. And so that's where normalization comes into play again. So we remember this. If you choose total in the normalization, that creates it where basically now it represents the Republican votes as a percentage of all the votes that were counted in that particular county. So this is just one piece of data, the Republican vote. If I go to Democrat, typically it's the inverse. And that's the case of these election maps is the Democrat and Republican quantities are usually inverse of one another. But how do we take the two and visualize them together in an interesting way? The way that I recommend doing this is using what's called the margin of victory right here. So again, this is when I took the Democrat count, subtracted the Republican count from that, and you get this margin right here. So let's visualize that margin. In field, I'll go to margin, keep normalization as the total vote. And then what we're going to do is we're basically going to adjust our classes here so that anything that is positive in the margin of victory is blue, and anything that's negative in the margin of victory is red, blue being Democrat and red being Republican. And the reason we do that is simply because since I subtracted the Republican votes from the Democratic votes, anything that is a Democratic win will be a positive margin of victory. So what we're going to do is we're going to create a new color ramp in here. And I created one that looks like this, where it's basically a blue to red. The classes here, and then choose this reverse values. And then that should flip it so that it's a little bit closer to what you would think. Now, this is almost okay, but there's some things that are not quite right. And this is when we need to adjust the histogram here. These ranges in the histogram need to be actually spaced equally for this to make sense. So we talked about the method here of how to represent the classes here. In the case of election maps, equal interval is what you want. What you can also do is you can go and increase the number of ranges to, let's say, 9. Now you can begin to see that the colors are a little bit more fixed. Now that you've done all that, you've essentially created a very simple election map that combines two data sets together using this margin of victory by simply subtracting the two data sets together. One thing about these election maps is that this map here is somewhat incomplete, and this is where we need to overlay another layer of information on top of this, because what this doesn't take into account is population density and the number of votes. What I'm going to do is I'm going to take this here and I'm going to copy and paste it. So I just Control C, Control V it, and that just creates a duplicate of that right there. Go to Symbology for this one. And we're just going to simply do this is just in the field here, just simply visualize the total votes. And then in normalization here, we'll do the area of the county. And so this is essentially very similar to population normalized over the area. And then what we're going to do here is we're going to increase the number of classes to, let's say, 9. And let's go to the method here and choose geometric. And then let's choose in color scheme here. We're going to do something a little bit interesting. We're going to create a white gradient, go into format color scheme. And we're going to create a color scheme where all the values in the ramp are white. And so I click on, for instance, the end here, make that white, choose the middle, make that white, and then choose the last color and make that white. But the last one right here, we're going to add a 100% transparency. So these two here are 0%, but this last one is 100%. And so what it basically creates is this gradient from solid white all the way to transparent white. And so I've created something like this. So what we have created, you can see this condition where in certain areas it's transparent, and in certain areas it's solid, and that represents population density in the United States. What I'm going to do is I'm going to inverse this. So I'm going to go to more, reverse values. Yeah, I want something like this, where the areas that are high in population, you can see through, and then the areas that are low in population are solid white. Because then what we're going to do is we're going to use these two layers here, and we're going to kind of merge them together using those Photoshop style filters. So I'm going to click on this top one here, go to feature layer, layer blend, and then choose something like screen or lighten. So let's choose screen. And see what's happening now is that this layer here is beginning to lighten up those areas of low population. And you can adjust this. You can give me to see, like, if it was 100%, this is the map that we originally had. So that's kind of what we're going for right now. Sometimes the boundaries of the counties get a little distracting. So for this overlay here, I'm just going to go in more, format all symbols, and outline color. I'm just going to get rid of that. Hit apply. And then this one right here, the primary election colors, we'll just simply go to more, format all symbols. And I like to either do this, which is to remove the outline color altogether, or what looks really nice is a white border. So I'm going to do white border with a 0.5 point thickness. So this here is your first example of a bivariate map. So we're going to go to insert here, and we're going to create a new map, and we'll create just a regular old new map. And in this particular data set, what we're going to do is we're going to bring back the map that we created last week, which was the Alabama block group map. Just choose Alabama east or west, and then click OK. And then now this is now a better proportioned state map. We're going to bring in the population data set for Alabama. And so we're going to use the join feature to join this to that data set. So right click on the county layer, choose joins and relates, add join. In the join field, we'll choose the GeoID. And then in all pop, it should be geography. This is the same thing we did last week. Then attribute table. You will see now that the race data and population data for all the races of Alabama are now back and joined into the data set. So we're going to right click on this guy, go to Symbology, and we're going to play with this thing called bivariate colors. And for those who have never seen this before, this is a bivariate legend. Think of it as like x-axis and a y-axis. So let's go in the field 1 line there. We'll choose the white. And whenever we represent population, we always try our best to normalize it to represent population density. So normalization, we'll choose the total. And then in field 2, we'll do black. And then again, normalize that with total. And now this is 2 factors. One is areas that are high and low population of white. And then the x-axis is a high and low population of African-American. So what you see now is super pink, hot pink. That is primarily dominantly white population. And then baby blue, the more baby blue it is, the more it is dominant in the African-American population. And then you see as it mixes between the two and gets to this more purplish dark blue tone, that is where you see that there is a little bit more diversity and a bit more of a mix. the way to change that is to go into this template button, choose that in the outline color, just make that no color, and then hit apply at the bottom. And now it's a little bit easier to read. And then what's always good to play around with is obviously the color scheme that you are working with. So right now it's doing this pink and blue scheme here, but GIS, they give you a bunch of options that you can mess around with. So you can pick one, let's say gold, blue, black ramp there. See what that gives us. You can also do this, which is in the grid size here, you can do more grids. So right now it's doing a 3x3, which is typically the recommended amount for these bivariate maps. But if you want to have more colors and have a bit more range in your color grid, you can always choose a 4x4. So I showed here two races, white and black or African American, as my two categories to map here. Another thing that, as you go through these examples here, you might want to play around with the orientation of the legend here. And so down here in orientation, there's these options that you can play around with. So if I choose this next one here, you see what happens to the legend is that it orients to a diamond shape. What's nice about the diamond shape is that it basically sets it so that all the lowest combination of the two factors here are at the bottom end of the legend, and then the highest of both are at the top. So it kind of just makes a very logical gradient word from low to high. You can play with label corners. So if I choose that, you see what happens is then it labels the corners of the legend. So those are just some things that you just can play around and keep in mind. All this stuff here, if you create a layout, let me just do that real quick, create a layout. You can also add a legend. We'll do that legend that we just created over there. And so when you export this out to Illustrator, you have that on hand. Okay, so that is the first version of a bivariate map. I want to show you one more version of a bivariate map, and that's this dot density option right here. And we're going to go to the dot density option right there. Fields, you can populate those with all the fields. So we're going to choose white, we're going to choose black, we're going to choose Asian. And what's nice about this here is that the density map already takes into account the area of it. Right now, dot value is 1, so it's too dense. So we'll take that 1 and maybe make it 100. So I take 100, hit enter, and that should loosen up the whole map so you can actually see it. So now you can see, yeah, basically in the urban areas, it has more population, and then in the rural areas, there's less population. And then what you would do is you would just choose your colors. So for white, you just click on that, choose the color. So if you zoom into this, you'll see that the population density is represented very nicely in this here. And again, as it gets to the rural areas, it loosens up. And so this generally speaking feels right. Okay, so that's map number, I think we're at map number 3. So what we're going to do now is we're going to create another version of this, and this is going to use the same exact skills that I just showed you, but we're now going to do it in Louisiana. New map, and we're going to add in a Louisiana data set. So I'm going to zoom into Louisiana, and I have in the box folder this right here, 22 BG 500K. These are the block groups for Louisiana. So there is Louisiana. I'm going to adjust the coordinate system again, Louisiana South. And there we go. Now Louisiana looks exactly like it should. So we're going to join some data sets to this. Let's bring those two in. There's attainment, which is educational attainment. And then the other one is income. So we're going to try to do a map that combines these two here. And the reason I chose income and educational attainment, what we're trying to do is find this correlation between whether educational attainment relates to income. So what we're going to do is we're going to join. So go to this table here, the map, right click, joins and relates, add join. And we're going to do the exact same method where you choose this AF GeoID. Then we're going to start with educational attainment. And then in the join table field, we use geography. So then click OK. And now in this table here, you should see all the degrees and the population, the count of that for each block group. And then the next table we're going to add, we're going to do join again. And this time we're going to add the income level. So in the input join field, we're going to choose this one right here. You see now when you join a table to a data set, it has to end a little thing in front of the field so that you know which field is attributed to each table. So we're going to choose this one here, this CB 2021 AF GeoID. And then in the join table, we're going to choose income and then geography. Now, one thing that you should do, I didn't do this last week, but it improves the performance and stability of the symbology and visualization of this, is that after you've joined a couple of tables to a data set, it's actually a good practice to right-click on that data set and export it out. And what that does is basically it bakes all of those tabular data sets into this data set here. So it's no longer joined, it's just permanently fixed to that. Export features. And in output feature class, it automatically saves this into your geo database. So I'll call this one LA for Louisiana, Census. We'll call this education. So those are the two categories that we joined. So click OK. Now you see that new shapefile has been added. We can take this old one, just turn it off. We don't need to use it. And then this one here now has all the data sets and tabular lines. They're just baked into this permanently. Now, what I'm going to do is right here, you see that the educational attainment, it's broken up by degree. So what I want to do for this particular data set is I just want to summarize higher education. So here's an intro to the field calculator. We're going to go to this field add button right here. If I choose add field, it brings up a new window. And so right here, this is all the fields. And at the bottom, it allows you to name a new field. So I'm going to call this one higher ed. And then in the data type, short and long are integers, just numbers. Float and double are also numbers, but those are numbers with basically decimal points. These are the four categories you should usually choose from whenever you're choosing a number. Just choose long for this one. And then what we do is you simply go to the top ribbon up here, and there's this save button here that saves the changes to the table. So we just hit save. So what we're going to do in this higher ed column here is we need to take all of the professional degrees and add them up, and then have that basically populate this column here. So right click on higher ed, then choose this calculate field button there. Then in this higher ed line right here, it says higher ed equals. I'm just going to go find the higher education degree. So we'll start with doctorate. So I'll just click on doctorate, double click on that. You see it brings it in. Then choose this plus right there. Then we'll go to professional plus masters plus bachelor's. So those are higher ed. I guess you can also add associates as well. It's a 2-year degree. One thing you should do is you should check this, click this check marks here, verify, to make sure that when you run this expression and it works, and in this case it says expression is valid. So then you just go down to OK and click OK. Higher ed has a number that represents the addition of all those degrees. Go to symbology, go to, let's do graduated colors first, and then choose higher ed. And so for the normalization for this here, what you should choose is total education. In this particular case, equal interval might be the best option. And so what are we looking at here? We're looking at essentially areas that have high educational attainment. Sometimes it just makes sense. I'm zooming into New Orleans right now, and this area with 80 to 100% educational attainment, this area right here is Tulane. We're going to quickly go to this bivariate right here, bivariate colors. And all I wanted to do basically was combine these two, educational attainment and income, to finish that potential narrative of these two factors. So in field 1, we'll choose the higher ed, and the normalization will choose the total education to show that as a percentage of the people who are counted. And then in field 2, we will choose the household income. And in this case, I don't think we necessarily need to normalize household income. What we need to do is we need to refine the histogram for both fields to make it a little bit more sensible. Let's go to field 1 here. This is the higher education. What we're going to do is we're going to set this to be equal interval, so that, again, it represents a bit more of a simple range. And you can see now areas that have lower higher ed now have lightened up a bit. So it's a little bit more something that you would expect. And then in the field 2 histogram, here is where you can be a little bit more intentional on how you represent these ranges here. You can actually, if you click on the little arrow here, you can actually modify it. And so what I'm curious about, and what I want to do is I kind of want that center band here to represent middle class. For today's tutorial, we'll simply set it at around 50K, put the higher range at, let's say, 125K. And what we have here is a map that takes two potentially related data sets and visualizes them together, where on the x-axis here, this is low to high income. And you can maybe say that the periwinkle color at the bottom corner here, this represents your lower class, the baby blue represents your upper class, and then this is your middle class. And then on the vertical axis here, this represents your educational attainment, with the hot pink representing a higher density of higher ed degrees. And so if we zoom into this New Orleans area here, it begins to create that picture of demographics in this area. And one way you can create this map, as I showed you last week, you can add a base map of the background of the aerial, then use this to color the map below it. So I'll click on the layer here, choose feature layer blend, and you can choose all these Photoshop style modes. Let's choose hard light. If you choose the aerial image, you can also give it a bit more transparency, so that's not so dominant. But now you kind of are beginning to formulate a narrative here. Okay. Custom base map is always useful to have, because it just makes it so that you can very quickly begin to parse out and understand the major urban areas and stuff like that. So New Orleans, Baton Rouge. So map making is easy and it's fun once you begin to get into it and you can play with the visualization and get into that. I wanted to show you two different types of raster data sets that I neglected to show in previous tutorials, but you should just know about, because they're very useful. There is a data set that's called this NAIP imagery right here. That is your agricultural imagery, and that's really nice. The way you download this imagery is the same way you would download a DEM. You basically just click the extend button there, draw a boundary around the area that you want to download data for, let's say New Orleans, check that NAIP imagery box, then choose search products. And then that brings up all these potential footprints that you can download and bring into GIS. I have given you naip.zip right here. And this is a 1 gigabyte data set of a lot of NAIP imagery. GIS. We'll go into the New Orleans area. And then what we'll do is in the catalog, we will go to the folder NAIP. You see all these images. If I bring in one as an example, you see one tile of that image right there. You can see it's a very nice high quality image. What we want to do is we want to take this and all these images here and we need to tile them together and stitch them together. So type in Mosaic and we're going to choose this create Mosaic dataset thing. Choose that in output location, choose that folder there. And we are just going to save this into your geodatabase. So I just click on the geodatabase. Okay. Mosaic dataset name, we'll call this one NAIP NOLA. Coordinate system here, this you basically just choose. If you brought in one tile, you can choose that tile and it will basically inherit the coordinate system that is already associated with that tile. You want to make sure that coordinate system is consistent in the Mosaic as it was in the original tile. And then these other two things here, don't touch those. You don't really need to mess with those. And then choose run. And then you see this Mosaic dataset has come in. Nothing shows up because now we've created a Mosaic dataset. Now we need to add stuff into the Mosaic dataset. So there's a second function called add raster to Mosaic dataset. So this is a two-step process. So we choose add rasters to Mosaic datasets. In the Mosaic dataset, we'll choose the NAIP NOLA thing we just created. This stuff here just leave as is. In input data, you choose dataset, and then you choose the little plus icon there, navigate to the folder that has all the images and just Control A and select everything, then click OK. That brings all that stuff in. In the raster processing, check calculate statistics, and in Mosaic post-processing, check update overviews, and then just choose run. So this is the result you can see here, and it has the original footprints as a green border. And this is the stitched together map here. What we want to do is we want to choose the image. So in the data set, choose image. And then in the Mosaic layer tab at the top, you can go to this band combination option, then choose color infrared. What you get is pink. And the reason this pink is good is because if you zoom into this is a very, very clear, easy to read understanding of vegetation in any area. And everything that's hardscape is generally illustrated as a bluish gray tone. So that is a map that I just really wanted to show you guys in. And the last thing I'll show you, and then we'll end today's tutorial in the links I gave you. This is high resolution bathymetry that you can download for most places in the United States. And so if you zoom in here, you can find basically terrain data that's continuous across the land and underwater areas. So what you do is you find an area that you like. Let's say it's New Orleans, this area here. You choose the GeoTIFF box right there, and then you hold the control key on your keyboard and you drag as big of a area that you want. And what that will do is it will allow you to download data for that area there. So with that selected, you just go down to the add to basket, view basket. And if you choose download your data, Amazon will mail you a basket and with a disk of this data. No, as a joke. It just creates a download link. But it would be really nice if they mailed you a basket, because there's nothing nicer in the world than a nice basket that you use as a gift to give people, right? Once that's downloaded, you go to your folder, extract that zip file, and then you can take that, move it to your data folder, and in there you have a TIFF file. That's your GeoTIFF. So go back to GIS. Let's turn off this here. Let's turn on the world imagery for reference, and then we'll go to catalog, go to the data folder that we copied that into, refresh. That's that bathymetry data right there. You can bring that in, and now you have your bathymetry data set right now, and choose a color scheme that has more colors so that you can see more detail. So you can choose one of these color schemes here. Anything that's a raster data set, you can hill shade and cut contours. To hill shade this thing, basically you go to the analysis tab at the top, raster functions. Here, choose raster functions, surface, hill shade, and then in that raster, you choose the file you just downloaded and just create a new layer. That creates that hill shade. Okay. That's all I want to show. I just want to just say there's another data set out there that is useful that you can download for that stuff. Also, one last thing, you notice how this is pixely looking right here. To fix that, you choose this option here called resampling type and choose this cubic. Should smooth it out. Stop share. That's all I want. So enjoy the rest of your day. Now you got a long day of classes as always. Survive. And don't die. Please. All right. Thanks, everyone.